Hello, everyone, and welcome to this workshop, Secure IoT Lifecycle Management with Pelion Device Management. So before starting the session, I would just like to remind you some housekeeping topics. So I have entered the call-in number into our Zoom chat in case of any audio issues. Today's presentation is being recorded and will be available within 24 hours on the Arm DevSummit site. So if you have any concern or question about the code of conduct, please see the FAQ on the Arm DevSummit site. And if for some reason the meeting ends prematurely, please try again the Zoom link right away. And if that doesn't work, wait 10 minutes to give us time to add a new link. So today we welcome your comments and questions for the speakers. Type any of your question into the chat box at any point of the workshop, and we will answer it on the chat or vocally. So I would like to introduce to today's speakers. So we have Maclain Lobdell, who is a technical account manager at Arm. We have Gary Sugita, Director of Marketing ICW Business Line at Infineon Technologies. And we have Mohit Kedia, Senior Product Manager of Pelion Device Management at Arm. So I think almost everyone just logged in. So I will let you, Mohit, start.
Absolutely. Thank you so much, Nice. Thank you all. Good morning, good afternoon, good evening, and thank you so much for joining. My name is Mohit Kedia, and I'm your co-host for the workshop today, which is brought to you by Arm, Pelion, and Infineon. The topic that we were going to discuss today is the secure IoT lifecycle management using Pelion Device Management and Infineon Cypress PSoC 64 part. So what is this session about? Today, this is a hands-on workshop that would allow you to experience the secure device management with Arm Pelion using Cypress, which is now Infineon PSoC 64 secure microcontrollers. The participants today would be able to learn more and perform secure onboarding, managing, updating the PSoC 64 kit with Pelion, and the participant would also learn how to implement the security at every stage in its device lifecycle, specifically for IoT devices. So the agenda that we have today, we would going to briefly introduce Pelion Device Management and PSoC 64. Then we would going to talk a bit more about technical concepts and demos. Some of the specific concepts that we would going to cover include root of trust, secure boot, secure connection and registration, secure services isolation using Trusted Firmware-M, and firmware over the update using Pelion Device Management. The concepts would be discussed, and then we would go through the hands-on part of the workshop with step-by-step tutorial. All the tutorial and all the steps that we are going to go through are also available online with the tutorial that we would share. At the end, we would do a quick session wrap up. And as Anis mentioned, if you have questions, please shoot out to us, shoot out your questions anytime. So looking into IoT, right, 2020 has been a very interesting year. IoT in 2020 have also taken a step change in adoption as per the Economist report for IoT Business Index 2020. What Economist is saying is that IoT adoption have increased substantially, and there has been a substantial increase in investment specific to IoT. Also, they have forecast that the investment would continue to go up. There is also a clear line of sight of business value, which I think was one of the key challenges in slower adoption of IoT, which no longer exists. And the next frontier in IoT is not just about connecting devices, but about generating value out of the data that you get out of connected devices. Also, security remains one of the top concerns for IoT devices, which is hampering the wide-scale adoption for IoT devices. If you want to read more about the Economist report, you have a link and a QR code in this page. So, as the Economist mentions, and a lot of other developers and the customers are talking to us, uh, data is power in IoT. The value of your IoT implementation depends on what is the value of data that you get out of those IoT devices. So if you are thinking about investing in IoT, start with the question of what data do you want with IoT and what is the value of that data. That would help you streamline your thinking across building the IoT plan. So we have been talking about IoT since last 8-10 years now. IoT is a simple thing in concept. What we're talking about is a simple sensor connects to the internet and provides the data. It sounds simple in theory, but we all know that if it was easy, everybody would have done it. There are many challenges in implementing IoT. Specifically, there are many challenges in implementing IoT at scale. Some of the key challenges include complexity, which means integrating different devices, different technologies, different systems together. Getting value out of data is also a challenge, and making sure that the data that you get and the devices that you deploy are secure is another key challenge that you face with IoT. All in all, IoT can be a challenge, and Cypress and Infineon, Cypress and Arm are here to help. As I mentioned, IoT is typically a complex deployment. You need, when you look into deploying a diverse IoT, when you deploy a diverse IoT implementation, you talk about the range of devices with a range of different silicon, many different kind of operating system, many different kind of devices, many different kind of connectivity options, and many different kind of cloud or uh, IoT device management platforms that you look into. With Pelion, we are abstracting the complexity and making it simple. Pelion makes it easy for developers, uh, to choose any chipset of your choice. It provides independence of selecting either ARM core or a third-party core, any silicon of your choice. We have a strong integration with Mbed, but Pelion provides support for any operating system or any SDK. Again, you have your choice. Whatever operating system or SDK you are continuing to work on, Pelion would support that. It also supports any devices, starting from ultra-constrained dumb sensors all the way up to the edge gateways, which are powerful devices, which are capable of doing local compute as well as controlling the devices below it. Pelion supports both the legacy devices, which are brownfield, also the greenfield devices, which are the new devices that you would develop for IoT. And all of those devices using Pelion, you can look at with a single pane of glass. Uh, Also, we support any deployment with cloud or with on-premise deployment options and integration to any data platform, any business application of your choice. So all in all, with Pelion, we want to take out complexity of developing an IoT device or developing an IoT deployment. So we talked about the importance of data. Data is really important for the value of IoT. You want to ensure that if you want value out of your data, you want to ensure that the data is secure and something that you can trust. You need to ensure that your data has trust. It comes from the endpoint that you can trust, endpoint that you can identify, and endpoint that has enough power that can send the data, that can mine and send the data over the internet. Pelion device management platform supports the secure device management throughout its lifecycle. As I mentioned, we support a lot of different kind of IoT devices across, which connects to Pelion Cloud, which provides you with smart connectivity, secure identity, device lifecycle management options, but also some advanced edge features such as application orchestration. Your lifecycle of the device is managed by Pelion, and the data that you get over the device is, it goes through Pelion pipeline securely into your web application, where you can generate value out of the data and generate value out of your IoT deployment. Pelion Device Management supports the entire device lifecycle, starting right from the concept up to deploying your IoT at scale, as well as offloading those devices from your network. During the design phase, it allows you to quickly do a proof of concept with quick start integrations and the device side integrations that you get. During the deployment phase, it allows you to onboard those devices securely onto the cloud. Pelion also enables a secure lifecycle management, which ensures that you can monitor and manage the device. You can update and upgrade the device firmware, and you can do a activation as well as the access control related to the device. At the end, when the life of device is over, Pelion also allows to take those devices offline and disconnect them from network or retire those devices. All in all, as a result, due to the complete end-to-end lifecycle, device lifecycle management solution, you can now focus on the IoT data and the IoT application, which truly generates value for you. Pelion provides unified operational view, unified security, unified identity, and allows you to focus on your IoT data and IoT application. Handing it off to Gary.
Yep, thanks, Mohit. Gary Sugita here for the IoT business line here at now Infineon from Cypress. So next slide, Mohit. Thanks for driving. So Mohit just said that IoT is all about the data, right? And so how can you trust that data at the end of the day? Well, trusted data comes from a trusted source. And so when we talk to customers about being able to trust that data, here are some questions that we typically talk about, right? Does it come from a trusted source? Was the device configured by authorized personnel? Is the connection authenticated and encrypted? Does the device run the most recent version of software? Does the device operate as expected? And only through that process are you able to ensure that you can trust the data that you're using. Next slide, Mohit. So, when data comes from a trusted device, on the bottom here, in green, red, and orange, I highlight some of the requirements. One is a chip with hardware protected environments. The second is to ensure that the devices are securely provisioned with the right credentials to be able to have the right, not only identity, but also be able to engender trust. And the third is to be able to manage those devices. And we're going to talk about how you can do that with Pelion. And Mohit just kind of gave you a preview of all that for the workshop today. Next slide. So let's talk about the chip with hardware protected environment. So it's a simple analogy that I like to use. On the left, you have a house with one room, and on the house you have on the right you have a house with multiple rooms that are isolated from each other. Mohit, if you can click the animation, sorry. So if you had a breach on the left, you could see that because it's one room, the whole house is breached, right? And on the right here, because the rooms are isolated from each other, rooms, and not only are you maybe able to identify that breach, but you're able to actually do something about it, right? This is known in the industry as just reducing the attack surface. If you look at how that translates to hardware, right? The isolation on protected environments translate to isolated processing environments, So on the diagram here, we have non-secure processing environment as well as secure processing environment. This is really established from the Arm Platform Security Architecture, or PSA Security Framework, where they talk about these different isolated processing environments, as well as even further isolation of a root of trust and trusted services, right? That's that trusted partition in the secure partition manager. In addition to that, Arm has contributed to some open source firmware to an organization called trustedfirmware.org, which actually enables a firmware example implementation of secure firmware for Cortex-M class devices. And then that's called Trusted Firmware-M, or TFM. It provides some standard PSA APIs for this, as well as the ability to have vendors like ourselves and Infineon actually certify to ensure that we're compliant to those standards in that framework. If you look at PSoC 64, I'm showing here the isolated processing environments and the device you're going to be using today. On the left, we have a Cortex M4 core processor, as well as the Cortex M0. And think of the Cortex M0 Plus as a secure coprocessor. And so on the left, on the M4, you're going to be developing your application, running Mbed OS as your operating system and the Pelion Device Management client. It also has access to our Wi-Fi host driver, as well as our peripheral driver library. And on the right, on the secure processor, that's where we're going to run TFM today. And that's where we're running this secure firmware with root of trust services as well, to be able to perform secure storage, even attestation and advanced crypto with hardware accelerator crypto on chip. The PSoC 64 devices are PSA certified, and actually we're going through PSA level 2 certification as we speak. Next slide. So what's the big deal about this root of trust? Well, the root of trust really provides an identity for access control. And another analogy I have here is that here you have a smartphone app, and trust is engendered through positive identification from a credential. In this case, a person's fingerprint or maybe a Face ID. And by using those credentials, you're able to identify you are who you are, who you say you are, and be able to actually get access to the app and the data that's behind that. But on the bottom here for things, right? How do you really trust that thing to get access to your app and data without an identity, without a fingerprint? So Mohit, next animation here. Well, we can do that with PSoC 64 in this root of trust, which is basically an immutable protected cryptographic identity that's used to securely identify itself and to be able to engender trust with your cloud application, in this case Pelion, to be able to get access to the data. Next slide. Okay, the second part of this is secure provisioning. And that's a really important concept that you have to understand, is that you want to be able to ensure that the devices have the right credentials and are done so in a secure way. So next slide, Mohit. So for provisioning, basically we start with a Cypress root of trust public key inside the device. From that, we can actually uniquely transfer that root of trust ownership to the OEM or to the developer. And in that process, we're able to actually establish your user root of trust public key inside the device, as well as establish a unique device identity that's generated from inside the device. Through that process, when we securely provision the chip, that's when we can actually start adding, in green here, your keys, your certificates and policies that you use. And we'll talk about how you can do that with Pelion certificates to be able to connect with Pelion. And the final step of this is to be able to use and load securely your user application, so that when you implement this, it'll cryptographically verify the image and boot up into a known good state. All right, next slide. All right, the last part of this is secure device management. And next slide. And Mohit touched upon this. I'm not going to go into a lot of detail here, but basically what I want to leave you a message here is that through every stage of the life cycle of your device, from provisioning to onboarding, through usage, updates, and decommissioning, PSoC 64 basically has secure features that enable you to manage all your device through every lifecycle stage securely, right? Whether that's provisioning with the right keys, onboarding with the right certificates, being able to control access to regular usage, and perform even verified firmware over-the-air updates to the device, and finally, lifing it through decommissioning. Okay, next slide. All right, so what we've done between ARM and Cypress, now Infineon, is we've basically enabled a solution that starts at the bottom here with a PSoC 64 secure MCU that works with Mbed, the operating system here that you will use today, that supports all the communication stack and the middleware for connectivity to the cloud and to Pelion. And from a security standpoint, we're using Trusted Firmware-M with these PSA APIs that allow you to gain access to that secure coprocessor. In addition, on top of that, sorry, Mohit, Pelion Secure Device Management sits on top of that for onboarding, managing, and update. And that's all PSA certified. So what we're delivering at the end of the day is a secure, scalable, and customizable device management solution. All right, next slide. So, what values does that bring? So, on green here, you're going to develop your application. In orange here, all the onboarding, managing, updates, all the security you need to implement, the communication stacks, middleware, your RTOS drivers, etc. Next animation, go ahead. That can take significant time, right? So if you look at percentage-wise, typical development might require you to spend time on device management and device stacks, while only allowing you, a smaller amount of time to focus on your application. But with what we're doing here with Pelion Device Management and PSoC 64 MCUs, that marriage of the hardware and the software and device management services really allow you to take care of that 80% right out of the box, so that you can really focus more of your time on that green box above, which is your application. Okay. So that's the introduction to PSoC 64. And again, we're going to go in a lot more detail as we go through the workshop. But I want to make sure that we have time to get you some hands-on capabilities. So I'll turn it back over to you, Mac.
Okay, let me share my screen and we'll move on to the next section. All right, thank you, Gary. Thank you, Mohit. Thanks everyone for joining. There we go. Let me see if that works. Okay. Yeah, so I'm Mac Lobdell. I'm a technical account manager in the Pelion group. And so I'm going to cover all the workshop, the hands-on stuff. So we went through the overview, set the foundation. So we have a little more foundation. So it's doing security really well. It's tricky. So it takes time and carefully going through all the steps. And we thought it's really good that we take a step back and go over some of the key technical concepts and provide some guidance before we let everybody loose. So I know we've been in presentation mode for a while, and we will get to the hands-on part, but I wanted to go through and cover how things all tie together from a security point of view. So don't quite start the tutorial yet. I know you received the tutorial link, and I hope most of you have gone through it a bit and got started. But we wanted to make it most successful after the class. We wanted to go through this information. So at any time, post questions. I've seen a lot of questions come in. Feel free to post all your questions, and our people that are on the line will get to you. So you should be very familiar with the Cypress board. You know, if you don't have it in front of you right now, it's okay. You know, you can go through it afterwards, go through the tutorial. But it's great if you're already started, and we can help. You know, live. We can answer some questions and things like that. So the tutorial that we provided is very thorough. We've added an extensive troubleshooting section at the end. So if you're having any issues, please check that out. But all the information should be there, and you can post issues in that repository, and we will be answering your questions there today and going forward. So please continue to do that. So we are using Mbed Studio. So and I'll talk about details there, but it's basically a desktop environment, IDE for building Mbed OS apps. And so it's quite handy for this lab. So Mohit and Gary mentioned PSA. You know, it's the manifesto for security from Arm and Arm partners, and you know, it's a set of security goals and key security functionality that really kind of cover all your bases when it comes to securing an IoT device. And you know, it's things like, you know, the unique identification, the security lifestyle, attestation, and so on. So if you look at the standard and you see all the security goals all spelled out, we're actually going to go through and talk about, or we'll talk about how all the concepts that I'm going to go through are related to all these security goals. So we have a thorough solution that covers most, if not all, of the security goals of platform security architecture, which is one of the reasons why this is a certified solution. So first concept, we'll go through provisioning. So devices are uniquely identifiable. So this, of course, the secure storage is the foundation for the identity and the security, and it's built into the hardware, which is great. And so Pelion uses this to establish mutual trust, you know, bidirectional trust, using public key infrastructure-based security with the, you know, the very mature X509 certificate standards. So jumping around a little bit, so with Mbed Studio in the tutorial, you're going to be actually using the terminal that is inside Mbed Studio for some of these provisioning commands. So that's their Python commands. You just open the terminal, and it's really convenient. So you don't have to install your own Python environment. You can use what's already provided in Mbed Studio. So what are we provisioning? So for Pelion, at least. We are provisioning, the first thing we're going to talk about is the Pelion Bootstrap Certificate. And this allows the service to trust the devices. So the Bootstrap Certificate is cryptographically signed by a certificate authority. So how is it created? There's three parts: certificate authority, provisioning tools, and then the devices themselves. And so this is actually, once you get a baseline provisioning done where the devices have generated their own unique key pair, so their own unique identity, the provisioning tools will make a request, and this is an authorized user, make a request to the device to get the device's public key. And so the device's private key, never shared, but it gets the public key. Then it takes that over to a certificate authority, whether you have your own or you're creating one as part of this lab with OpenSSL, or you use your enterprise certificate authority. It's making a certificate signer request. The certificate authority will sign a certificate. It now becomes an identity certificate, and it will get injected back into the device. And so this proves ownership of the device's private key, which is kind of like saying, I am who I say I am. So it's quite helpful. Pelion doesn't, you have the flexibility to use your own certificate authority. You're your own boss, essentially. with Pelion Device Management. So you actually upload a certificate from your CA, your certificate authority, to Pelion. It's signed by the CA's private key. It proves ownership of the CA's public key, and it's the root certificate for the certificate authority. So you actually upload that, and so you upload that, and then now essentially Pelion will trust your devices because they will have a certificate that has been signed by an authority that you've made Pelion aware of, essentially. And so when does this certificate get injected? Well, like Gary mentioned, through the chain of trust, we're using the Cypress Infineon tools to inject the certificate, where at the same time it gets policies and keys and things like that. And then later on, we'll talk about how you add your user application on top of all this. So summary provisioning, real quick. The tools generate a key pair. The device generates its key pair. It's unique per every device. Then you generate a unique Bootstrap certificate for every device. It's signed by the CA. The CA certificate is uploaded. And then there's another set of keys that I'm not going to talk about now, but that's for the secure boot. Just to mention that also gets added at this time. Okay, so what does provisioning look like? There's a list of commands, but if everything's good, and you've gone through the troubleshooting guide, everything is connecting and working well. It's authorized to be able to erase some sectors internally. When you're initially doing this in development, you're basically allowing it to be re-provisioned again, which is very nice for your sanity during development. But once you go to production, you're going to lock that down. You're going to not enable re-provisioning so that it's very secure. So in this case, we can see that I re-provisioned and re-provisioned passed. Okay, so what does it look like to add the certificate? It's quite easy. You go to the Pelion Device Management portal, upload a certificate, you give it a nice name. You don't want to upload your key, you want to upload the certificate, and then now you've successfully told Pelion, if you see devices signed by this, you can admit them. Okay, so so now we've talked about, okay, how now Pelion can trust your devices. How can your devices trust Pelion? Well, of course, another certificate. There's a lot of certificates. So with this, the Bootstrap certificate, it's like another root certificate. It's basically your device can verify signatures it receives from the service, so then it knows that it's authentic. So now you have established mutual authentication. Now your device can trust it's connected to Pelion. Okay, so there's a couple different modes that Pelion supports. One of them is fully provisioned, where you get all the information, including what Pelion account the device will connect to. But in cases like white goods or cases where manufacturer creates several products that go to downstream customers that then customize them and connect them to their accounts, we have first to claim, where devices are enrolled or claimed later using information that I'll mention in a second. And so we're using first to claim in this case. It's quite easy to work with. So when you enroll the devices, you need a unique fingerprint for every device, and it's called an enrollment ID, and it's calculated from the device's unique Bootstrap certificate. And enrollment IDs can be uploaded in bulk or one at a time, and we'll upload it one at a time as part of this tutorial. And then so the Pelion account has your certificate, CA certificate, then it has the enrollment IDs, and then it can enroll the device and connect it to your account. So Pelion will recognize your devices. So here's an example of enrolling. So in this case, so most of the time in the production environment, you're going to get all these enrollment IDs out through the factory. In this case, the device will print it on the screen of the serial port. You copy that, and there's actually a gotcha with Embed Studio for copying. So just check the troubleshooting guide. You just have to copy, and it should work fine. But it may not look like it's working. But essentially, you copy that enrollment ID over, then you press the character C to continue, and now that's going through the Bootstrap process where it's exchanging more information through a secure tunnel that will complete the process and connect it to your account. Okay, so that was a long section on the first concept. Second concept is Bootup. So this supports PSA Framework number 4. Devices only run authorized software. And the way this is supported, like Gary mentioned, immutable, a secure bootloader infrastructure. So it's immutable boot code, launches a signed bootloader. That bootloader verifies signed user image. So there's a chain of trust there, and you have good assurance that it's only allowed to run authorized software. So this is where that user application key I mentioned comes into play. The applications are signed by another key. This time you hold onto the private key, so you have the keys to your castle. So you keep that securely. You signed your images with that. The device will have been provisioned with the other side of that, the public key, with the certificate that allows it to verify that signature on boot up. And so Embed OS has built-in hook that will call CUI secure tools. It's a Python package, and that handles signing of the image. So you really don't have to handle anything once you generate the keys. You just have to press build, and then the application will get signed. So now your device can only boot authentic software. And so summary of provisioning, you have all this information. It's all been injected into the secure storage, including now the user application public key. Okay, what does signing look like? It's really what does building look like? It's so once you've set your Wi-Fi credentials in the tutorial, once you're ready to build, you just click the trusty hammer, and it goes by quickly, but you can see in the post-build script, it's putting some serial data out that the boot area is signed successfully, upgrade area signed successfully, and so on. And then, yeah, before you build, set the Wi-Fi and SSID password. Okay, so the next concept is connecting and monitoring. So this supports things like all the security lifecycle items mentioned, like decommissioning, commissioning, decommissioning, things like that, and then making sure devices can be securely attestable as to what version they're running, and so on. So they have to be securely connected and be able to monitor them. I'll mention here a tutorial note. You have to make sure that you set the device target ID correctly. So we are using, maybe I should have moved this to a different section, but we are using a different version of the target name that has TFM, Trusted Firmware-M, enabled or included. So make sure before you build, you set the target name correctly. Okay, so then, so Pelion Device Management uses lightweight machine-to-machine, or LWM-to-M protocol for its device management operation. And that also provides you with the capability to have digital representation of device resources. So whatever resources you define for your application. So you can do things like monitoring your device's health, get alerts if conditions exceeded. And I should point out that this is compatible with other cloud, data management services that you might be working with in your products or in your enterprise. So an example that we have in this example application is quite simple, very simple. It's just an automatic counter. It just goes every second, counting up that data. The count is exposed, and of course, you as the application developer control what you want exposed or not. You can control whether you can get, put, post, any of that. So in this case, we're allowing get and put on this resource. It's a digital counter. You can get the value, and then you could put it and to set it back to whatever you want, or set it to any value you want. Okay, so here's a quick overview of how you monitor your device. So you get the device ID, you go to the device management console, you look at, if you locate the device, you can go to the resources tab, and you can look at all the URIs, their lightweight M2M, way of addressing resources, and then you can edit. In the case where it's post or put, you can edit the data, and so it's a bidirectional way to communicate. And then we've actually enabled, and of course this is very optional. So the post is enabled, and well, actually, so we have a post resource. We have another post resource that will reset the device if you wanted to remotely reset it. So I'm sure there are certain cases where an authentic user would want the capability to be able to do that. So you have that flexibility. Okay, so the next concept is Trusted Firmware-M. So Gary mentioned this. So it supports the PSA framework. It supports isolation, interaction over isolation, unique binding of sensitive data, and a minimal set of trusted services. So I won't go into too much detail because Gary covered it, but essentially there's secure storage, attestation, and crypto within the secure processing environment, and emBedOS takes advantage of that, and the Pelion Device Management client takes advantage of that. And an example of how it's used is that during the TLS handshake, when it's initially connecting and exchanging keys, Pelion makes a request to the secure environment to sign a blob of data, and this action is performed by TFM, and this is without ever exposing the device's private key, which of course is ideal. Okay, so I got a lot of questions about where everything is located in the memory. So essentially there's internal flash, you have TFM, you have the emBedOS application, and then you have update image areas, and then in the external storage is where we're storing the non-secure environment application, and so you can update from there, and then you have additional space in the external quad SPI for your application. Okay, so I believe this is the last concept. So firmware update, devices need to support updating their firmware. Of course, bug fixes and security patches. You don't want them to be able to be unauthorized, have an unauthorized rollback. So there's yet another certificate I need to mention. So it's actually firmware update manifests, which describe the firmware payloads, are signed by a private key that you generate, you own. And then the public key and the certificate are stored in the device. And so this allows the device to authenticate a new firmware update before it downloads a payload. So now your device can verify the payload before downloading it. So you can save power if there's any issue, of course, and you can block any attacks that might occur. So how do you get the certificate? Well, it's actually just there's a manifest tool. You initialize that tool, and then you get the files in your file system. So this update default resources file is your own unique update certificate that gets built in to your application. Okay, so how does a firmware update campaign work? Well, you imagine you're the device administrator or developer. You upload firmware and manifest to the service. Then the devices get an update notification and the manifest, and they will respond with, they'll accept it or not. If they accepted it, the image will download. The device will store it, and then it will reboot. It'll copy it into internal memory if it all looks good and is authenticated, and then it will boot the new image and then report the status back to the service. So I mentioned manifests. I just want to mention, so they encode information about the firmware update. They're cryptographically signed. Attributes are things like serial numbers of your device, location information, whatever you want to put in there. And then filters, you can use filters to define subgroups. So let's say you want to update, devices in California, Northern California at 5 a.m. and Eastern Europe and some other time. You have that flexibility when you're creating update campaigns. And so there's another important information to have as you're going through the tutorial. You need an access key. So this is it's like an API key if you've used Pelion before, but we have a new concept where you're creating, you're specifying an application. You want to have a specific application be able to access Pelion, and then you want to generate a key for that application, and you want to give it a time limit. So you copy this big long string. You really have to save it securely because the Pelion service will never show you this string again. So make sure that you store it, and then you can use it, and then it can always be revoked by the administrators if there's any issue. So launching update campaign, so you can actually, here, I'll mention that later, but so we're gonna use a script to a nice command line tool to update the campaign or to start a campaign. It's gonna handle all the things I mentioned, like uploading the manifest and the firmware. And then an important thing to note, so the firmware version format is very important. So it's using a 64-bit unsigned integer. So in a JSON file, we're gonna set a number and it's gonna be like 1.2. Well, you have to convert that when you run the script, you have to convert it to the first 32 bits being the major version before the dot, and then the last 32 bits to be the minor version. So you end up with a large formula or a large number times the major version plus the minor version. So it's quite straightforward once you've gone through it. So I want to mention, so authenticated users, of course, can run firmware update campaigns from the device management console, from the command line tools like we're going to be using, and then also through the REST APIs directly. So you can integrate Pelion with your existing enterprise cloud infrastructure. So how do you launch a firmware update campaign? Well, so we're going to set that version in the file. We're going to convert the output to the right format. We're going to run the campaign. It's going to tell us that it's publishing. And then you can go into the device management console and you can see that the update is pending while it's downloading. And on the device, you'll see that the image is downloading. And then, it takes a good 5-7 minutes to complete the whole process. Of course, in a real application, you could slow that down or maybe speed that up. I don't know, but depending on your power consumption requirements. So essentially, it will reboot, copy it over, reconnect and register to the service. Okay, so I hope everybody has a lot of great information, or that has a lot of their questions answered, and has a lot of the information to help them as they go through the tutorial. And I will walk through that live. Maybe since I rapidly went through all that, we could stop here and answer questions. But essentially, we will. I'll go through the tutorial after this point. So maybe some of my colleagues, maybe we want to pick out some common questions.
I think most of the questions have been answered already on the chat. So I guess we can go ahead with the tutorial.
Okay, excellent. So let's see.
And please post any questions you have as we go through the tutorial on the chat. And
yeah, so I guess
Gary, we lost you. I think you are muted.
You're muted.
sorry about that, my my computer. Does everyone have everything installed, all the prereqs? Everyone has a kit? I guess I just want to do a quick check-in before we get started.
Do we have the voting?
Oh yeah, you know what? In
enabled?
the chat box, I think, or I think it may be the participant view. Can you see? There's a button for yes, no, go faster, go slower. Maybe you can just vote to make sure that everyone is good to go. If anyone is not installed everything, I just want to know that as well.
Let's see. So
Has
let's
everybody
just
found the voting thing?
I have not. Maybe because I'm presenting, I can't find the voting. But if you let me know, I will be happy to help with any specific issues. So let's just move along. So I'll just go through the tutorial. So you should have Embed Studio installed, and if you're on Windows, there's some libusb information you should check out here on having the right version. And I think before the meeting today, we got some additional feedback that you need to make sure you have the right version, 32-bit or 64-bit, depending on your version of Windows. It seems to follow your version of Windows, which could be different than your version of Python. And then for doing the CA certificate, we're using OpenSSL. I'm on a Mac here, it's all built in and it works. But for Windows, there's a distribution. So everybody should be able to import the application into their Embed Studio environment. And then, so as I mentioned, and we had a little video, if you go, you click the little arrow here, click the chip icon, and then you can select your connected device. And I've already changed the name. So I basically modified what the default name is for this board. So you should have CYTFM and so on. And that's in the guide. And then an important thing to do is to set your Wi-Fi SSID and password, and that is in this file, embed app.json. And at risk of showing my SSID and password, I should have thought of this before I did this. So if you're driving by my house, I'm going to change this. So make sure that you're editing the characters between the second, inside the quotes here, So just, I mean, just make sure you edit the characters, not the slashes and quotes. So that will be, you know, for your access point that you have in your house. You do need a Wi-Fi access point to do this lab. And then, so make sure that if you're in Embed Studio and you happen to close Embed Studio, reopen it, there's a little gotcha with the latest version where you have to make sure that if you have a terminal window open, you need to close that, reopen it. So the way you open a terminal is go to Terminal and then New Terminal. And then now you're in a fresh environment, and you should make sure you can check, well, you can check the Python version, Python -- version. It should be 3.7.1, and it should be, you know, within the Embed Studio. I think I have to do Python 3. Yeah, it should be within the Embed Studio environment is the version of Python that we're using. And then I'll use this terminal here. So, and then in this terminal, I go back to the tutorial. You will install the CY secure tools. So you should be able to go pip install CY secure tools. I'm just going to check. Let's see if this works. I'm going to check that I have it using pip list, and I can see that I have CY secure tools 2.0.0, which is the correct version that we're using in this lab. And then, okay, so now we're going to be going into the provisioning. So we're doing it in a two-step process. So one of them is the first time only to, you know, set the baseline of you know, have it generate its keys and initialize everything. So we're doing that in a different location than we will later. So you have to change your directory down into within Embed Studio, or sorry, Embed OS. So I'm in the folder for the, probably hard to see. Let's see if I can bring this up a bit. Nope, still hard to see. But I will change my directory. Depending on where you're starting from, you need to adjust that command a little bit. Okay, so now I'm down in the depths of Embed OS where the target information is for this target. And then you initialize the CY secure tools at that point. And then you create keys. And those are, you know, unique to you. You might be asked to overwrite them. I'm not going to go through it now just because I already have my boards provisioned. If you have any issues at this point, go check out the troubleshooting guide at the bottom of this tutorial. And then, so first time provisioning requires adjusting a jumper to set the power supply voltage rail. I believe it's for blowing some fuses. And so you remove jumper J26, plug the power back in, make sure the mode for the board is set correctly, and then run the provisioning command. And then if all goes well, it should say provisioning passed or reprovisioning passed. So maybe we should stop. And then of course you put the jumper J26 back and power it back up. So maybe we should stop here and see if there's any questions that we can help with. And you know, for me, if I can run it live, let me know if you want me to run it live. But all the information should be available, and if not, let us know. give me 1 second. I'm going to stop sharing my screen and then.
Yeah, I think there was one question which might be common to a lot of people. So we say press the mode select button and then the LED should start blinking. So it's just press and release. You guys don't need to press and hold it. If you guys do press and hold it, I guess over a couple of seconds and then release it, you go into the KitProg bootloader mode, which does begin to blink, but it's an awkward pattern. So if you want to get out of that mode, just press and hold and release again, and then for over 2 seconds, and you should be fine. So just in case people run into this, mode switching issue.
Thank you, Sri Harsha. Okay. Yeah, so yes, we are plugging into the USB, can reach it, on the side of the board here, and the LED should be blinking that frequency. Okay, any other questions at this time?
Yeah, real quick, what security pieces went into the part in that section? Which keys, which certificates, etc.?
So the first provisioning section, it is, and Sri Harsha will be the expert here. It's getting your security policy, your security. There's a public-private key pair, and then the application public-private keys are set at that point.
Yeah, and I think I can. Yeah, so let me answer that difference between the first and the second. So the first one is basically exactly like Max said. We are doing just a provisioning call which asks the device to generate a unique key pair, which you're going to use later to form the device certificate. As well as basically because of the way the tooling is built today, we also provision things like, hey, here's a public key which you're going to use to sign your firmware, and these are your memory maps. But you will actually kind of rewrite those once you run that secondary script in the next step. But the only reason we ran the first step was to make sure that we have a device key pair which we can read out to form the certificate. In your actual production, when you go through your manufacturer, they'll probably do this in a single step. So
nothing here was Pelion specific. This was just configuring the part.
That is correct. Although I think, there might be some things which you don't change. For example, the memory maps, which was shown previously in the demo, which says, hey, this is where my CM4 application is, this is where my TFM application is, stuff like that. Although we will be rewriting it, I don't think we'll be modifying it in the next step. So
that is true. And I see there's a question about, if you'd provisioned in the past and you want to read out information about it again. I believe that's called the entrance exam command. Is that correct, Sri Harsha? So you can run a command, you can, or am I getting that mixed up?
Well, sorry. So, I did this days ago. Okay, yeah, that should be fine. So if you guys already kind of went through this and provisioned this, that's fine. If you run the next script, which is the reprov helper, the device key gets generated only once and it's secret. So it'll just send out its public key and you can form the certificate and put it back in. So you can always reuse this current kit in this form. So even if you did this days ago.
Okay. So a word of caution though, for later on in the lab, when you're, if you go through all the steps again, it's a good idea to re-enroll the device and kind of clear out its internal memory, especially if you're changing things like the update certificate. It gets stored in the device's secure, it gets stored in a separate area of flash that Pelion uses. And if you're changing that, the service can get a little confused and so you just clear that and then run it again. So I can mention that later. Let's move on, and so now we'll get into the second stage of the provisioning, where we're getting into generating that Bootstrap certificate. So you are going to a different level of the file system. You're going to make a folder called certificates, and then we're going to use an OpenSSL, a set of OpenSSL commands to create your certificate authority. And so you should be successful in going through that. If everything's successful, you should have a set of files in your certificates folder, including the root ca.pem file. And then, like I mentioned earlier, you upload that into the Pelion Device Management console, and I guess it's a good time I could actually show the Pelion Device Management console. So you have a nice dashboard. You can see information about number of devices connected. If you go to device identity and certificates, you can see a list of certificates, and this is the certificate that I have previously uploaded that these devices are signed by. And a very important note is that, let's see, I'm not sure where it's shown, but you need to make sure when you select what type of certificate is, you need to select enrollment. So here it is. So production enrollment / bootstrap versus a developer certificate. Okay, so then in the second round of provisioning, we're kind of doing some similar steps here to set up a slightly separate environment. And then you run the script, and in this step, you will give it your own serial number. So this is kind of for a demo application. This is a little extra step. Normally, this would be in your production. It's going to use the serial number of the production devices. In this case, we're just passing in a long string of digits. So when you run that, you pass in your own serial number. Okay, then you run that command. It's this reprovisioning helper script. So you complete that, and now, yeah.
Mac, there's a, I mean, I think there's a comment that you may be going a little too fast. I got a private message. So
okay,
just to confirm, I mean, I like, let's kind of take a quick pause and make sure people are there where we are. So
yeah. So I should point out we are available to stay longer. I know I'm really rushing to get through. This is, unfortunately, it's not something to, if we had more time, we would made this session a longer session. So really this is kind of the primer to give you information as you kind of do the homework to complete everything. So we will do our best, and I'm happy to slow down and help as people are going through different steps.
Yeah, I think the Zoom chat is sometimes a bit hard to navigate, so just trying to figure out a better way to do this. So, well, I've got a couple of people who I'll help out in parallel. I think that's fine, but I think it's just if everybody's comfortable with this. So,
sure. yeah, again, we will be available for a bit longer, and we will help with if you go to this repo, later after the session, feel free to put in an issue here. We'll be keeping an eye on it. You can, if you're having a problem, again, I know it's a lot of information right now, but if you go to the troubleshooting section, let me mention that. So things like if the Python commands fail to run, if the provisioning tools fail to connect, these are little gotchas. I've mostly for me, my typos, my little mistakes here and there. So I've collected this information, little tips to help. So in a virtual environment, it is tricky to do a hands-on lab and have everybody at the same level. So I can pause for a little while. Yeah, and we totally acknowledge that this is quite a lot of information and a lot of steps, and so that's why we've spent a lot of time putting together the tutorial and the videos, and we'll be available to help as much as we can as you go through that. So once you've completed the provisioning and the board's ready to go for programming at that point, you set the Wi-Fi password. You're going to have to initialize a manifest tool to get your update certificate, and then you want to go ahead and build, but make sure you have your Wi-Fi SSID and password set, that you're very sure it's set correctly. Otherwise, it'll basically rebuild, do a clean build. So you need to make sure the JSON is fully ready to go before you build. And building, so building an Embed Studio, it really depends on your system that you're running on. So It could be anywhere from 2 minutes, and I've seen very worst case 20 minutes when it was an old laptop with a bunch of corporate image stuff bogging it down quite a bit. So I would expect most people, you're building in about 2 to 5 minutes. So there's also a couple ways that you can flash. The initial time you connect to the board and you flash, you can just run the application. This should work. It should be fairly reliable. So you click the run button, and then that will download to the internal flash and start the application. You can also manually drag and drop. So this board is in DAP-Link mode, which has drag and drop capability. So you can go find your application once it's built. And there's quite a lot of files. You want to make sure to get the long name of the application .hex, and you drag that over to your DAP-Link drive, and you give it a little time, and then that will load it. And then in Embed Studio, it should already just bring open this serial monitor. But if it doesn't, you can go to View and choose Serial Monitor. And if I go up to the beginning of my application, oh, I might have ran out. I'll go ahead and give it a reset. You can see what the start of the application looks like. So then the first time it boots up, I'll have to get the enrollment ID. And I mentioned a little gotcha in this version of Embed Studio. And this applies also when you want to copy the device ID. So if you notice, I click and I select, it's actually you can't tell the text is not getting highlighted, but trust me, it is getting highlighted. If you Control C, you will copy the text, and then you can paste that. So you'll need that bit of information for the enrollment part and for copying the device ID when you want to do a firmware update. So you can see my device is running 1.8. And I'm going to go ahead. Well, let me before I do that, I'll show the resources, what the resources look like. Okay, so if I go to device directory and devices, and I click on the device that's registered. Registered, devices are services designed to work with sleepy devices that come and go. Registered is kind of like available, but there's data caching and digital representation of data that can remain even if the device is asleep. So if I look at resources, I'll go to that digital counter that I mentioned in the slides. So since I was resetting and changing and it's getting reset, it's actually going down, but it's starting to count back up. And then I can set it. I'll do a put and change the value. And that'll drop it down. And I should see in the terminal that the counter was set to 2. Okay, let me, okay, so I mentioned access keys, and we saw that video on the access keys. I'll provide a tip on where to, I'm stuck. The Chrome thing. There we go, okay, so then you can go to access management and you can create an application. And then you go to access key and then set a new access key. So then you copy that long string. You want to save it on your computer. And you can create an environment variable if you'd like. So you can use that in some of the commands. Okay,
Mark,
I think a lot of, yes.
Mark, do you think that it's like, can you show how people can update like a specific set of devices using the portal and creating the filters just to showcase and visualize how this is done to update some specific set of devices with using the filters and the attributes?
Yeah. Yeah, absolutely. Let me, before I do that, let me kick something off and then I will do that. So let's start by, I'll show a, doing a firmware update. And then I'll talk about, I'll do it on one device and then I'll talk about how do you do that on a, you know, on subgroups of a fleet. Okay, so I'm going to change the version in our policy file. And then recompile. Okay, I can see that the images are signed correctly and the application has been generated. And then the next step is, let's see if I have it. We have a special upgrade payload that just has the information required to send the firmware update. And we need to convert it to a binary. And I need to be in the correct folder for that. So let me make sure I'm in the right spot. Okay. Okay, so I've correctly converted the file to the right format. And then if I go back, I will I'll show the, actually before I do that, let me show you a handy little script for calculating that version of the firmware. So to convert it to that 64-bit unsigned value, I'll just put in the 1.9, which is the new version I want to convert it to. And so you can see it's this long number there. So I should have, let me verify the device ID. So it ends in C8. So if I go back to the serial monitor, my device, yes, it's correct, it's C8. So in this case, just for development, I'm going to update this one device. And of course, using Pelion Device Management, you can update thousands and thousands of devices using the REST APIs or the portal. The command line makes it easy for demonstration purposes, but all the features are available in the REST APIs in the console. So there's flexibility there. Okay, so I'm going to go ahead. So I'm pointing it to the payload. I am telling it what version I want this new version to be. I'm going to say I'm telling it to update one device. That's when it's connected. Have it update, and then it's going to the script is going to basically handle everything as far as uploading the manifest, uploading the firmware, and so on. So I just updated this device earlier. So the new campaign is in the publishing state. And so if I go to the device management portal and I go to firmware update and then update campaigns, I should see there is an active firmware update campaign. And I can see that it is pending. So if there are any issues, you'll see them here. You'll see if it's been successful. And it's quite handy if you have a lot of devices that you're updating. You can see the details of the update campaign. So if I go to the device, I can see that it's already started downloading. And again, it takes a few minutes to download and flash it and complete the process. Okay, and then, so like Christos mentioned, normally when you do a firmware campaign, you want to target a subgroup of devices. The way that you do that is through device filters and custom. You can set custom attributes. And so like I want to add a custom attribute and I want to say the location. And I think the example we used in the video was in our office. And so you can save that. And then when you're selecting device groups, you can add a group and you basically do a filter when you want to do a firmware update campaign. you can select select the filter. So I'll have to defer to this video for the details. So I'll show it in this nice video. So again, you go to attributes, location, and then that key information that was escaping me was going to the device directory and then filter at the top right. And you filter on a custom attribute. And you can give it a name. And then when you are doing a new campaign, you can select the device filter of your devices. So it's very flexible. So let's check on our device.
This feels like one of those screensavers with a moving thing, huh? Kind of hypnotizing. Yes, let's just wait for
Yeah, it's like the Matrix. Or
yeah, I mean, yeah. Well, we're close though. Yep.
Getting closer, getting closer. So I can look at the status of the campaign.
And just
well.
I guess this might be an open question also, right? I mean, when we are updating, are we updating both the application and the Trusted Firmware-M piece, or are they handled independently right now?
So they can be handled independently. Right now, we're just updating the non-secure side, the Embed OS application side, not the Trusted Firmware-M.
Yeah. Okay. So it's just the Embed OS application. Okay.
Yes. Okay. So we've downloaded 100%. And it'll take a few seconds to boot up the new application, or take a couple minutes actually to boot the new application. And then we can monitor the state.
Hey Mac, there's kind of an open question which talks about a linker issue where there's multiple things to find. Have you seen that before?
I was just looking at that.
Yeah.
I'm not seeing a difference between the two files that they're listing. They look identical. There's some small file name difference. Perhaps a clean build. It's not an expected error, or not an error that I've seen. Okay, so the device completed. So essentially it authenticated that the firmware update manifest was signed correctly. And then it downloaded the firmware. Then it's the bootloader, which is from Cypress, or it's based on MCU boot, is interrogating that storage, looking at the application, making sure that it looks good. It's also verified, gets copied in to the internal memory, and then it gets booted, and then again it's checked for authenticity and integrity, and then the new application is booted, and so now it's reconnected to the service. So now we've once we got through, you know, all the steps, all the tutorial information, which you know, we will help you get through. Doing a firmware update is almost effortless. So with all this great security, so this is the goal here, that we really work towards realizing the benefits of IoT by taking, you know, the great hardware and software pieces and putting it together into a platform that really helps application product makers. So that is our goal. And if I go back to the tutorial, or I actually go back to the portal, you can see that this campaign, our small campaign on one device, was completed successfully. So again, all the little video clips, all the information about enrolling and building is all available in this tutorial. Shall we attempt to vote to check where people are at, or if anybody would like to, or if anybody's having any issues you want to highlight, feel free to do so.
Max, should we ask people to just type in the chat, like, are they through provisioning? Are they still onboarding? I guess where are you guys in the status of the lab?
Yeah, that we could go that route if everyone wants to. I guess if you have completed provisioning, maybe type in that you've successfully completed provisioning in the chat. That'd be helpful. Okay, so we have someone updating the firmware. That is fantastic. Okay. So this is the point in the lab where we are, people are working and where everybody's walking around and helping and checking on things. So maybe I should shut up, let everyone work. So then, well, I just said that I would shut up and then I started talking, but so timing wise, I don't want anybody to miss other sessions. So we're still good. So we have 2 hours in our slot here. So we have roughly 15 minutes. But again, I think we could stay longer.
There was a question that popped up in the chat that it asks, is there a reason all this provisioning hasn't been integrated into Embed Studio tasks?
Essentially it's, we're using the Embed Studio Python environment. Cypress has their Python tools that can run in different environments. So yeah, I haven't heard of, additional kind of hooks and integration into Embed Studio, but that'd be interesting if you have feedback on that.
Mark, it's great to see workshop attendees answering questions from other workshop attendees. It's really great to see this.
Yes, thank you, everyone. Maybe I can mention a few of the troubleshooting tips. I think I've already mentioned several of them. but you want to make sure that your Embed Studio terminal is correct. So if you need to close it, reopen it, that can help. You want to make sure that the board obviously is plugged into the right place, the right debug interface. If you're on Windows, the with USB. For provisioning, so we found that if something failed for one reason or another, it can help if you try to run the reprovisioning command and add the erase boot option, and that can reinitialize the flash on the device. And then when you're building an Embed Studio, you want to make sure to have the target name said correctly. And I should have mentioned this earlier. So not that it necessarily would have an impact, but it could. And so Embed Studio is very nice and allows you to easily update sub-libraries for components like Embed OS, Embed Client. So you might say, see a little icon, update to the latest. Well, we haven't tested this application with the latest. Many times it'll work just fine, but just in case, don't bother updating all these things because that could cause an issue. Could be debugging different things than other people are. And then, yeah, like I mentioned in the embed app.json, make sure you have made edits cleanly in that file. And then one important thing is if you don't upload the root certificate, the right file, and then that is the correct file that was used to sign the Bootstrap certificates in the device, it can result in a network error because it manifests itself as it can't do the exchange. It's like it can't validate the security, so it can't do the network exchange. So that can happen if you don't have that root CA set, if you accidentally changed it like I did about a week ago, and then I had this problem. So keep that in mind. And then, so if I think somebody was mentioning on the chat, if like you're changing update certificates, things get in a weird state. If you happen to update to a new update certificate or things get corrupted, you can use this PyOCD. It's a Python tool to erase the flash in the during development. This available is unlocked to erase. But what you want to do is you want to flash the device with new firmware that has the new certificate that you've reinitialized things. Then you want to erase that internal storage and then let the device boot up. And that way it will save things in the right locations. And the reason for that is, and this is for development stage. The reason is if you, as soon as it boots up, it'll save things in the storage. So if you want to change the storage, you need to flash it with the new file. So hopefully that information is clear if you ever run into that, if you go through that. And that command is actually useful in case you want to do the enrollment again. You just clear that storage and then it will re-enroll to your Pelion account. And then I mentioned the Embed Studio copying issue. If you copy, it actually is working fine. It's just it's not visible. And the Embed Studio guys have told me that they are fixing that in the next version. And then on firmware update campaigns, it's important to note that you can't have multiple ongoing campaigns that target the same devices. That can be confusing to the devices, of course, and to the service. So the service prevents that. So if you ever have an ongoing campaign and you need to go in and stop that campaign and then start a new one if you want to target the same devices. And then similarly, if there's a problem with the update certificate, you might need to go in and reinitialize it in case you might have changed it. And then when you want to do a firmware update campaign, make sure that you set the version correct in the file, the policy file, and then you calculate that 64-bit number correctly. If you don't have that calculated correctly, it will not work. And you need to use a newer version, and so you can't go back. You can't go use a lower version to update it to. It's got to go forward. So there's no rollback. And then make sure you convert that file correctly. And then, of course, use all the right device ID and access key that apply. And in rare cases, during development, we saw that if the firmware update campaign didn't get started, it can help speed things along by pressing the reset button. So we'll check the chat. If anybody is having any issues, let us know. And maybe in about 5 minutes, we'll start the wrap-up process.
Hey, Mac, I'm not 100% sure, but I think the Zoom might end at the 2-hour mark.
Yes, I believe it will.
Okay. So, and then in the wrap up, you also talk about how people can contact after this if they need some help or support.
Yes. Yeah. Why don't we go ahead and mention that? So again, this tutorial should be your friend, and we will help you as you continue with it. And if you didn't get through, it's fantastic. We've had some people reporting some successes there, so it's great to see. Yeah, we'll hopefully you have a good overview and a good primer for how you can use PSA compliant PSoC 64 MCUs and Pelion Device Management for managing your devices securely through their life cycle. And there's some great documentation, thorough documentation available on these topics for the PSoC 64 and the Pelion Device Management. And if you, again, post an issue on that GitHub repo, we will monitor that. And you can make a support request or product request at pelion.com. And if you want to reach me, I'm available as well, maclobdell.io. But I think we're about 5 minutes out. So I hate to end abruptly. But it's been a pleasure doing this and working with everybody. So we will be there to help you going forward.
Thank you, Mac, and thank you everybody for joining. Please take advantage of some of the resources that we have put in for your help. And also, as Mac mentioned, please contact any of us, in case you're getting stuck or if you have any questions. Thank you so much for joining this meeting, and hope the last 2 hours, the content that you have received in last 2 hours was useful. Thank you.
Thanks, everyone.
Thank you.
Thank you, everyone.
Okay, yeah, I think we have about 3 minutes left, so I guess we will wrap it up. And thanks everyone for joining.